Two-sided marketplaces are a great way to resolve supply and demand inefficiencies. There is such high demand for great programmers, but there is only a limited supply. So why would it make sense for a great developer to use a terrible tool like a job search engine? That's why I love Hired.com. Developers can sign up at hired.com/softwareengineeringdaily and be connected with 5 great job opportunities at companies like Stripe, Uber, and Facebook. If you're a developer, you shouldn't settle for a mediocre job. And I know this from personal experience. It will stunt your career growth. Hired will give you a $2,000 bonus if you find a job. And if you go to hired.com/softwareengineeringdaily, you will get an additional $2,000. It costs you nothing to try it out, and it's a fun process. I urge you to try it out. WebTorrent is a streaming torrent client for the browser. Feross Aboukhadijeh is a developer working on WebTorrent. Feross, welcome to Software Engineering Daily.
Thanks. I'm happy to be here.
In order to explain how WebTorrent works in more detail, we should talk about some of the requisite technologies. And I want to talk about BitTorrent, which is one of the requisite technologies. But before we go into the specifics of BitTorrent, I want to go broader and talk about peer-to-peer technology as a category. Could you define what peer-to-peer technology is?
Sure. It's interesting. I mean, the internet is peer-to-peer technology, if you think about it. I mean, any two computers can connect to each other if they know each other's addresses. The internet is a big peer-to-peer system, and it's only with systems that came later, like the web, that were built on top of the internet, where we kind of lost some of that peer-to-peer, that inherent peer-to-peer nature that was already there.
Okay, so in a peer-to-peer network, such as the internet as it was classically created, every peer is both a client and a server relative to the other nodes on the network. What are the characteristics of a client and a server in a peer-to-peer network? Like, how are they? How do the nodes on within the peer-to-peer network? What are their obligations to one another?
It's a bit abstract, but I think the core thing about a peer-to-peer network is that everybody can contact everybody at any time. There's no notion of like a server that listens and can receive messages from anybody, but a client that can only connect to servers, but that can't be connected to itself. So that's kind of that's one thing. And then typically in peer-to-peer systems, you see this property where everybody is participating in helping to keep the network alive in some way. So there's not a lot of there aren't a lot of peers in the system who are shouldering like most of the burden of keeping the system alive. So something like the web, you have web servers that if they were to go away, then the web would go away. Or if one web server goes away, then part of the whole web goes away, right? Everything that server was hosting, all those URLs are now broken because the URL refers to the location of the content, and that location is no longer reachable. So typically, I mean, this isn't like a hard and fast rule, but what you see in a lot of peer-to-peer systems is that they're designed to not have these flaws. They're designed to be more resilient and to make all of the peers on more of an equal footing. So that you don't end up in these situations where networks are brittle, or where they have topologies where you see like the star formation, where there's like one thing in the middle and like thousands of people all connected to that one thing, right? That's a very weak topology.
Sure. Okay, cool. So now we have some notion of what peer-to-peer is. So let's discuss BitTorrent. BitTorrent is a communication protocol for performing peer-to-peer file sharing. How does BitTorrent compare to the older peer-to-peer protocols that were used by networks like Napster or Kazaa?
Okay, so I'm actually not very familiar with those older networks. I actually learned.
Oh,
I know. I actually learned this stuff when I started taking a look at BitTorrent. So those were actually before my day a little bit. But I kind of have an idea of where BitTorrent improved things. I know that a lot of the older peer-to-peer systems used to be pretty primitive when it comes to actually getting the files from people. So when you connect to somebody, you basically just ask them for a file, and then they send you the whole thing. And if they go away or they're slow, then you have to just deal with that. You're basically it's like a direct connection, and you're just getting the file from usually one person. But BitTorrent is smarter than that, right? You can actually get the file from several people, usually dozens of people at the same time, because you can get pieces and then reconstruct the pieces and produce the final result. And you verify that the pieces that you're getting are what you expect. So there's a notion of integrity as well. It's not possible for a peer to send you malware or to send you garbage data instead of the file that you're actually expecting.
great. So I'd love to get into that in more detail. Describe so I think this moves us towards the discussion of a distributed hash table, which is how you could think of a particular file that you want to download. If you're a client and you want to download some file off the BitTorrent network, you're pulling all these little file pieces from different essentially indexes off of a distributed hash table across the network. Can you describe this in more detail? Like, what is the model for the distributed hash table across the network?
So the distributed hash table it's interesting because it's just used for finding peers. It's a replacement for what are.
Oh, so I was wrong.
Yeah. I mean, it's possible to actually get to get data from the DHT, but the way BitTorrent uses it is for just finding peers. So I mean, I can talk about that if you want.
Yeah, please.
Yeah. So basically, the BitTorrent DHT is a way to take what the BitTorrent trackers used to do and to make and that is to help you find peers. So to find who has the files that you're interested in, and it's basically taking that and making it decentralized. So instead of connecting to a single server and asking that server, please tell me people I can, IP addresses of people I can connect to who have this file that I'm interested in, and hoping that server is able to respond and able to handle the load. You instead make every single client in the system a mini tracker. And so it's actually an amazing engineering feat, really, and one of the coolest ideas in computer science, I think, because it works without any central coordination. So every peer basically in the system decides that they're going to be responsible for keeping track of the peers who are interested in some subset of all of the torrents in the whole world. And they do this by picking, every peer picks an ID when they start up. And this ID is, you can think of it as like a number in a big number line. And it's somewhere between 0 and a really big number, 2 to the 160. And every torrent in the world is also a number that's somewhere on that same number line. And so if your ID happens to be close to some torrent ID, then it will be your job to keep track of the people who are downloading that torrent or who are seeding that torrent. So the people who are in the swarm, the torrent swarm, as we call it. So yeah, everybody just does this, and then and so it kind of splits the work up among everybody, and it's not that much work when you have 10 to 20 million BitTorrent clients online at any given time, and then now you need a way to kind of find who you should ask when it comes time, like when you actually want to go download something. So say you have a torrent hash, right? Or which is basically a magnet link or something, and you want to now find which peer in the system you should ask to find out that list of IP addresses that you want. Those are the people who you're going to eventually connect to and get the file from. you need some way to kind of traverse this distributed data structure, which is the DHT. And it's probably not easy to explain like over audio, but like let's just say there's a way where you can provably within like a pretty quick amount of time, so a certain number of hops, you can find exactly who is the person who is keeping track of the peers for the torrent that you want. And it's actually provable that you can do this in O of log n time, where n is the number of nodes in the network. So for like 10 to 20 million nodes in the network, that's around average of 20 hops. So just by talking to 20 different people, you very quickly narrow down and find exactly who you should ask. So it's amazing actually that it works.
So let's say if I want cat.jpg, so I can just ask the network, and within 20 hops, I know who all the different where all the different pieces of cat.jpg will reside. Is that correct? Or could you walk me through that example?
Yeah, sure. So let's first walk through the example of how you would find who has cat.jpg in the old model, the way that BitTorrent used to work for many years, which is with a tracker server. So the way that would work is when you add that torrent to your torrent client, it would see that there's a tracker server listed in there. So it's just like an HTTP URL of a server that it knows it can ask for peers. So it sends a message. It sends an HTTP request to that server and says, "I want this torrent," and the server responds with a list of IP addresses and ports. These are IP addresses and ports of people who are downloading or seeding the content. And the way that the tracker gets this list is everyone who's ever downloaded that torrent in the past, or who's seeding that torrent, every 15 minutes they all send a message to the tracker saying, "Hey tracker, by the way, I'm still in the swarm. I'm still downloading or seeding this." So the tracker just makes this list out of all the people who've contacted it in the last 15 minutes, and who have said that their torrent client has this content available. So then when I want to get that list, I just send a message to the tracker, and it adds me to the list, and then it also responds with the list of everyone who also has the file. Does that make sense?
Yeah.
Okay, so that's how it keeps the list up to date. And so every 15 minutes, my client is going to be announcing this, and it's going to be getting a new list of peers that it can try to connect to. Now, in the DHT, I want to basically get the same list, but I'm going to be getting it from a random person in the world. And so first, I have to do the 20 hops to find who to ask, and then so when I find that person, they're going to respond with that list of peers, and then I have to connect to all those peers now to actually get the file data. So there's just like a two-step process. I have to do a little bit of work now just to find the peers. It's not as simple as a GET request, an HTTP GET request to a server. And then once I have that response, then I have to do the second step, which is to actually connect to these people. And then that's where the BitTorrent protocol itself comes into play. And that's where, you actually do the piece requests and get piece responses, which is, pieces of the file.
Mm-hmm. Okay, great. So we've been talking about kind of the lower level protocol, and I want to zoom out for a while to put this in some broader context. So before you started working on WebTorrent, the user experience that kind of was the optimal thing anybody could imagine for BitTorrent was really bad. So describe the user experience of somebody who had to consume the BitTorrent protocol and why it was so awful.
Well, I mean, that's interesting.
From a UI perspective, or I guess from the end user experience. Totally,
yeah. I mean, there was a time when BitTorrent was like state of the art, and where it was one of the easiest ways to get files, and it's in a way it's not that different than a web browser in that first you download the browser, the torrent client, right, and then you need to get a URL. In the case of a torrent client, that's a torrent file, and then you give it to the thing, and it goes and gets the content that you requested. But These days, I think like people sort of expect better from their just from all the services that they use, and the standard's been raised by YouTube and just by different various video streaming sites. So people expect to be able to just push play and have it work. And so if you're a site owner and you're considering using BitTorrent as a way to save money, to save bandwidth, that's not really viable, because you're basically asking your users. One second, sorry. Phone's ringing. Yeah, so let me repeat the last sentence. What was I saying? So if you're a site owner and you are considering BitTorrent as a way to save bandwidth costs, you have to remember that you're going to be asking your users to do a whole bunch of extra steps that they wouldn't have to do before. So they might not know what BitTorrent is. They might not have a BitTorrent client installed on their computer, so now they have to go do that. And then after all that, they have to then come back and click the link to download your torrent file, and then open that up in the torrent client, and they have to wait for the content to finish downloading, which could take a while. And then once that's all done, then they can start to watch it. So there's no streaming, which just makes for an overall worse user experience. And so it's just not something you can actually do. No one would, no company who offers videos is going to offer them over BitTorrent unless they're really desperate. So you see some people actually doing this who are really desperate. Like if you look at the Internet Archive is trying to archive all of the whole internet, and they're really strapped for cash, and so they offer a lot of their content over BitTorrent. And if you're trying to download some random archive video from the 50s of I don't know, some black and white, I don't know, maybe earlier than the 50s, the 20s, or some period of time that's no longer in copyright, and you're trying to download that video, you might be willing to put up with BitTorrent to get that archival footage or whatever that you want. But the average user is not going to do that.
Right. Okay. Well, so that brings us to your ideal vision for the user experience of your project, WebTorrent. So what is the ideal vision that you're trying to build?
So WebTorrent is a BitTorrent client that works in the browser. This means that you can go to a website and it can fetch content in a peer-to-peer way, and it can show it to you right there in the web page. And you don't have to install anything on your computer. You don't have to install browser plugin or install a separate program on your computer. It just works. So you have the exact same user experience of browsing the web normally, but it's peer-to-peer.
That sounds like an awesome goal. So what are the problems with getting to that user experience? What are the hurdles that we need to jump from a technical point of view?
So WebTorrent requires a technology called WebRTC to be available in your browser. Fortunately, it's available in Chrome and Firefox and Microsoft's new browser Edge, and also Opera. So so you need WebRTC. That's one thing. It's pretty widely deployed. It's going to only increase. So that's a good thing. But if you really need it to work for like Safari users, then you're out of luck. So assuming you have WebRTC and you're using a modern browser that supports all these new standards, then the next challenge is to find peers who have the content. And if the content that you're hosting on your site is like, let's say you're a video site and you are already hosting all your stuff on an HTTP server, so on a CDN or something like that, maybe Amazon S3 or whatever. Then WebTorrent actually has a really cool way of creating kind of a hybrid torrent. It's a way where you can basically say this content is peer-to-peer, like get it from peers if possible, but there's also an HTTP URL where you can get the file from too. And so you can tell WebTorrent to go and download this, and then tell it to show that video in a video tag on your page, and it will always work because there's always that HTTP URL there that it can fall back to, even if there are no peers. So if you're the first person to come to the page, then you'll probably get it. You'll definitely get it over HTTP. And then once you have just the first bit of that video, you're now sharing that to other people who will come later. So this is actually a really nice way for sites that already exist today that have all their stuff on HTTP to kind of create a hybrid site that's peer-to-peer when possible, but that doesn't sacrifice the availability of the files when there are no peers online.
Wow. Okay. So that's a super interesting end use case I didn't quite understand before this conversation. Engineers are always looking to simplify. To simplify testing and deployment, engineers turn to CodeShip. CodeShip is continuous integration and delivery as a service. With CodeShip, your tests are executed against your code automatically whenever you push to GitHub or Bitbucket. On Software Engineering Daily, we've done several shows about DevOps, and continuous deployment is key to DevOps. It's a great way to break down the wall of confusion between development and operations. Managing your own testing infrastructure is painful. That's why you want a service like CodeShip to do it for you. If you have a huge number of tests, you can use CodeShip's Parallel CI to run all your tests in parallel. CodeShip will spin up containers on their own infrastructure to run your tests in parallel. If the code passes your tests, CodeShip will deploy it automatically to your users. Companies like Product Hunt are already using CodeShip to speed up and simplify development. To sign up for free and start shipping today, go to codeship.com. Or to try out CodeShip's new Docker platform, go to codeship.com/Docker. In order to understand how WebTorrent works at a lower level, we need to understand the three types of nodes that are participating. So we have the classic BitTorrent clients that people use on their desktop to download files. So these are clients like uTorrent. And then we also have WebTorrent.js clients that run on web pages. But these two types of torrent clients cannot communicate directly with each other, which is crucial. So you need a layer of communication between them that brokers the traffic between a desktop BitTorrent client like uTorrent and one of these WebTorrent.js scripts that is running on a web page. So as I understand, this is like really crucial. And so I'd love to know, like, is what I said correct? And explain it in more detail to the listeners.
Sure. Yeah, that's a really good question. It comes up a lot on the GitHub issue tracker, actually. So the WebTorrent. So WebTorrent is incompatible with existing clients, and that's not because we wanted to make it that way. Obviously, it would be awesome if every client could talk to every other client. It's an unfortunate limitation of the way WebRTC works. So the browser has to follow this special connection model because it wouldn't be safe to just allow a browser tab to start making random connections from your computer because it could connect to random services on your local network, like your printer or your router or whatever. It's not safe. So WebRTC has a more complicated connection model. Instead of just knowing, so if you think about TCP, in TCP, to connect to somebody, you just need to know someone's IP address and their port, and then you can send them messages. You can connect to them. It's kind of like sending a letter in the mail. To mail somebody a letter, you just need to know their address, and you write it on the envelope, and then you put it in the mail, and it'll arrive at their end. WebRTC is more complicated than that. So it requires an offer and an answer. So it's kind of like getting introduced to somebody. It's kind of like getting set up on a date. It's actually a good way to think about it. So to get set up on a date, you usually know a mutual, you and the person know a mutual friend, and the mutual friend kind of brokers between the two until you finally connect directly. So in WebRTC, to make it concrete, the way it works is if I want to connect to a peer that I know is out there in the world somewhere, I create an offer, which is just a blob of text that describes my connection, so my IP address and my port and some other stuff. And then I give that offer to some middleman. It could be a server, it could be another peer, and then that message, that offer, gets transferred over to the other peer I want to talk to. in some way. It's not defined by WebRTC. Your application can get that offer message to the other person in any way you want. You could send it via carrier pigeon if you wanted. Then when the other person gets it, yeah, when the other person gets it, they produce an answer based on the offer. The answer contains their IP address and port and some other information, and then that gets sent back to you via some other, again, via some undefined channel. And then now that we both have, so now that I have an answer and the other person has the offer, we can finally connect directly to each other. And then you start to have true peer-to-peer connection at that point. So before that, you have to go through a middleman. And this makes it safe to do in the browser. So just to answer your original question, just to make it clear, so because we have to do this different connection model, we had to make certain changes to the protocol, to the BitTorrent protocol. But we only changed it in order to support WebRTC. And so we changed it in the most minimal way we could. So other than this one change, it's exactly the same as normal BitTorrent. And so we hope that other clients out there like uTorrent and Transmission and Vooz and all the other ones will adopt WebTorrent. And in order to do that, they just need to support WebRTC as an additional connection type. And in addition to the two that they already support. It's actually interesting that there's already a history of BitTorrent actually adopting new connection types over time. So it all used to be TCP based, and now it also supports UDP, which is actually more efficient. So WebRTC could just be another one among the two that are already there, and then we'll have three different ways for peers to connect to each other.
Okay, so we will get into WebRTC in more detail, but in order to illustrate the explanation that you said, could you connect that to the example you gave? So like somebody goes to torrenttube.com and there's a video, and I want to play the video, and the video is going to play just like you described, where it will potentially go to just a predictable link, like the way links normally work on the internet right now. But it'll also it would use WebTorrent if WebTorrent were available. Can you connect that simple end user example to the technical explanation that you just gave, and what would be happening on the back end in the case of the WebTorrent use case?
So are you asking like what would happen if existing torrent clients supported WebRTC, and then like a normal web browser user just went to a site and was able to get a torrent from them?
Yes, I'm asking for the kind of the end-to-end explanation of when you go to the web page and you click play on the video. Like if you go to WebTorrent, if you go to the WebTorrent homepage, I think it's webtorrent.com or webtorrent.org, and that video is playing. WebTorrent.io, right? So when that video is playing, what is happening? And on a lower level, like, given the technical explanation that you just gave, how does that me clicking play on that video translate to what's going on at the torrent level?
Yeah, good question. So basically, what's happening is when you go to webtorrent.io, we include like there's a magnet link in the page that describes.
What is a magnet link?
Oh, sorry. Yeah. So this is kind of a tangent, though. Do you want me to explain it right now?
Yes, go for it.
Okay. So before magnet links, there were just .torrent files, and torrent files are kind of like URLs for torrents. The only difference is a URL describes the location of content. That's what a URL stands for: Uniform Resource Locator. And so, it's describing the location. So if the location, the server that has the content goes away, then the content is unavailable. So that's a broken link. We see broken links all the time on the web. So a torrent file, on the other hand, uses this thing called content addressable. What's it called? It's basically content addressable. I'm forgetting the third word. Basically, a torrent file it doesn't use the location of the content. It uses the content itself as a sort of address. So you can think of it kind of like a fingerprint. Yeah. If I know someone's fingerprint, I will know when I find the real person because I can check their fingerprint and say, oh, this is the real person. So if I can tell you the person you're looking for has this fingerprint, here's a copy of their fingerprint. Once you find the real person, you'll be able to check that it's the real person because you compare their actual fingerprint on their finger to the fingerprint that you got in advance. So you identify the thing you're looking for by its fingerprint. And so that's what the torrent file contains. It contains a fingerprint. And in fact, it even contains many fingerprints. It splits the file up that you're looking for into many pieces, like 1,000 pieces. And it has a fingerprint for each one of those pieces. And that's how you can actually get different pieces of the file from different people and check the fingerprint of each of the pieces and make sure that you got the right data. And if someone gives you a bad piece, you can immediately know that they're a bad peer and you should stop talking to them and stop trusting them. And you don't have to wait until you get the whole file to find out, oh, dang, the fingerprint is wrong. Now what do I do? Because I wasted an hour downloading this huge thing and it's wrong somewhere, but I don't know where. I just know it's wrong because the fingerprint is wrong. So, in the way we actually do the fingerprinting is with hashing. If you're familiar, like SHA-1 hashing or MD5 is another hashing thing that people use. Yeah, so it's just a way to kind of succinctly describe the content of something, and it's like a one-way function. You put in some stuff, you get out a small, succinct fingerprint, and if you change the input at all, even a little bit, then you get out a completely different fingerprint. So anyway, a magnet link is basically just a more succinct way to represent the torrent file. So if the torrent file contains these 1,000 fingerprints, that means that it's going to be pretty big. It's going to be like maybe a few kilobytes, maybe even hundreds of kilobytes. So it's not very easy to refer to something by 100 kilobyte description. A link would be nicer, something that's really short and so that's what a magnet link is. It's basically just it's a hash of the whole torrent file itself. So you basically hash that even one more time, and now you get just a simple little hash that's only 40 characters. And then what you do is you ask the network, the peers, to give you the torrent file. And if you hash the torrent file and it comes out to the same hash that was in the magnet link, then you know they gave you the right torrent file.
Okay, so we've got an idea of what the magnet link is. I'm sorry I deviated you. Could we still go through that end-to-end example?
Yeah, sure. So the page has a magnet link in it, and so when the JavaScript starts to run, it takes that link and it says, all right, my job is to download this file and play it in this video tag. So it finds some peers. It uses a tracker server right now that I'm running, and so it asks that server who has this video. And the server replies. It connects to those people, and it starts to fetch the file data using the BitTorrent protocol. Now, the people it's connecting to are all sorts of different types of clients. So there's other people who are on the same page as you that are sharing the file. There are also some people running Node.js programs that are just sitting on their server, just seeding this content, seeding this video to make it available more. And so those are just like random node programs on random servers out there that are also participating. And those are also WebTorrent nodes. But what's interesting about those node programs that some people are running is that since it's Node, Node.js can do anything that a program on your computer could do. So it can do TCP and UDP. So those Node programs are actually sharing that video to normal BitTorrent clients like uTorrent and Transmission as well. So we call those hybrid clients because they can talk to both the normal existing network of BitTorrent peers and the browser peers as well. And slowly over time, we're hoping that those normal peers will become hybrid peers by adopting WebRTC. So the number of hybrid peers will increase. But today, when you go to WebTorrent.io, you're just going to get, you're just getting it from people running these special Node.js programs and from other people on the same page as you. And we also have a web seed in there as well. So we also have the content on an HTTP server so that it can use that if there's no one else online as well. But these days, if you go to WebTorrent.io, you'll see there's a lot of peers online. There's usually at least 20 available at any given time for that video on the homepage.
Right. Okay. So, and we should dive into how to make this work at a lower level. So you've described this 3-step plan that you need in order to make WebTorrent usable. And you said step 1 is to build a JavaScript BitTorrent client for OS X, Windows, and Linux. Step 2 is to make Node.js code run in the browser. And step 3 is to use WebRTC to create peer-to-peer connections. Why are each of the steps of this plan crucial?
So I think you found that probably on an old GitHub issue from a long time ago when I was just starting the project. That's it's funny because I haven't heard that plan in a while. So the plan was roughly like this. I thought that, so for step 1, I should probably, as an individual developer, I didn't understand BitTorrent that well. So I thought before I try any of this stuff, before I try to make this crazy idea work, I should probably understand how BitTorrent works. So I wanted to just write a BitTorrent client just to understand it. So, but I knew that I needed to do that in JavaScript so that most of that work could be reused when it came time to make it work in the browser. So that's what I did. There were already some existing BitTorrent clients on NPM, the Node package manager, that I could use as a reference. But I basically wrote one from scratch, and then it's actually surprisingly easy to get something like that working because you don't have to be a good peer at first. You can just be leechy. You can just basically send messages to the network and get what you want and not be a very good peer, and it'll kind of work because there's enough capacity in the network for that. So it's actually really good for getting started. It's, you can just write something that just barely works and then improve it over time, and that's sort of the approach that I've taken. So once we had that, then the next step became, okay, let's make it work in the browser. So then we made the changes to it so that it would work with WebRTC. But what I actually learned along the way that was kind of interesting is that I could structure the WebTorrent project in such a way that you could include that JavaScript file either in Node or in the browser and have it work. So it's the same exact code base. And if there is TCP and UDP available, it'll use it. And if there's WebRTC available, it'll use it. So in the browser where WebRTC is just built in, it'll detect that and it'll start connecting to those kinds of peers. And in Node, where only TCP and UDP are available by default, it'll use those. And if WebRTC happens to be available in Node as well, it'll use that too. So it just kind of does what it can, and depending on the environment it's in, and it's the same exact npm package. So it's just called WebTorrent, and you can use it in either place. So that's kind of cool. So then,
right,
yeah. So now you have this. Now you have these. Now you have a pretty good. Now you have a client that works in both places. What was the third step? I forget. Can you repeat it to me?
Well, you were saying to use WebRTC to create peer-to-peer connections.
Yeah, so that's the part where we got it working in the browser. You got it working with WebRTC.
Yeah. Okay. So to clarify, I mean, in step 1, you wanted to build a JavaScript BitTorrent client, and then step 2, you wanted to make the Node.js code run in the browser. So to clarify, you were taking all the code that you wrote for the BitTorrent client in step 1 and just porting it to the browser in step 2, right?
Yeah, I mean, like I said before, it's really just changing the way that the transport layer works, the way that you open connections. After a connection is opened in the browser, everything that you do after that is exactly the same. So if you can write your code in a way where you abstract the type of stream that you're communicating over, and you basically, once you have an open connection, you treat all of them exactly the same, whether it's TCP, UDP, or WebRTC, then you can make the rest of the code exactly the same. So 95% of it is exactly the same in both places, and there's just this extra connection type that is used when WebRTC is available. Does that make sense?
Right. Yes, absolutely. And so to build on this explanation of your development process, the tools that you used to execute this plan are NPM, Browserify, and WebRTC. So this is maybe like sort of the explanation of why is this possible now? Or, I mean, why is this easier now? Like NPM, Browserify, and WebRTC, maybe this would have been feasible in the past, but it was certainly made a lot easier by these tools. So I'd like to kind of go through these and like talk about the importance of these tools. So for example, NPM, how does NPM, NPM, you talked about the importance of being able to break your components into small reusable parts. How does NPM embody the best way to do this?
So that's a great question. I think that NPM is one of the best ways to learn how to structure large applications, just by looking at the way people do it on NPM. It's interesting because it solves the problem of dependency hell that you have with a lot of other package managers. So instead of installing things globally, you install them locally to your project. So you don't need to use like a lot of the hacks that other people in other programming language communities have to use. Like in Python, there's a virtual env to like make it so that your things install locally instead of globally. So when you have that allows you to then depend on a lot more things and not worry about having two things in your dependency tree that depend on different versions of a shared dependency. So, because if that ever happens, then you're really screwed, and you have to basically get rid of one of your dependencies because they're both depending on different versions of something, right? So NPM is really good for that. So you see in the Node community is people just writing these really small packages that do like one thing. That usually a lot of packages are just one function, and then you can depend on that and not worry that it will cause a conflict with it won't make your package less appealing to use because you have dependencies. So what you see in a lot of other communities like Python is that any library that wants to get a lot of adoption or is used by a lot of people will have no dependencies, or very few, and they'll try to inline as much as possible. So they're basically, I mean, in essence, copy pasting things from copy pasting functions from other places and putting them into their package, so they can say they have no dependencies. Because if they had a dependency and you had a different version of that dependency, you wouldn't be able to use their package. So So that's kind of cool. So given that, then so when I learned about this, I was like really excited. So I decided to write WebTorrent in as modular a way as possible. So every piece of it is a different package that you can use on your own if you only want to do like that aspect of a torrent client. So for example, if you want to just create a torrent file and you want to just do that, you don't want to actually do any torrenting. Let's say you're just building a website to let you drop files on it and gives you back a torrent file. You can do that with one package called create torrent. If you want to just parse a torrent, so you want to take in a torrent file and then produce a list of all of the data that's inside of it as a JSON object, that's a different module called parse torrent. If you want to connect to a BitTorrent tracker server and ask it for some peers back, that's a different module called BitTorrent tracker. If you want to connect to the DHT and ask the DHT for peers, that's called BitTorrent DHT, and on, right? So then what WebTorrent does is it just requires all of these packages and ties them together with a little bit of glue code, and then you have a torrent client. So It's really actually quite nice because there are other torrent clients that are written in JavaScript that can use the same dependencies that WebTorrent uses. So it's actually maybe in a sense not good for the WebTorrent project that I'm doing all this work in these modules and then someone else can come along and make a competing torrent client. But I don't care because this is a better way to do software, and that means that like these sub dependencies get a lot of bug fixes and get a lot of attention because they're used by a lot of other people in a lot of different other projects.
Well, certainly, and I mean the virtuous cycle goes the same way. They might make some small modular dependency that you could easily swap out some suboptimal modular dependency that you've built into WebTorrent, and you would have an improved project. And even if they've taken a bunch of code from you, then virtuous cycle or whatever. So totally. But what about Browserify? So Browserify is heavily used by WebTorrent. Could you, we've glossed over Browserify in previous episodes of Software Engineering Daily, but I'd love if you could explain what Browserify is and why it's so useful to WebTorrent.
Sure. So if I were to state what Browserify does simply, I would say it makes node style require work in the browser. So the browser doesn't have a require function to let you require modules. And so if you have code that's written in that style and you want to make it work in the browser, you need to transform it. So Browserify is a very simple transformation from code that is written in this require style, and it makes it work in the browser.
Okay, and so how was that so useful to WebTorrent?
Well, WebTorrent was originally, like we said before, it was written as a torrent client for Node. So being able to just take that code and make it run in the browser, it was greatly helped by having Browserify.
Right. Okay. Perfect.
And one of the other things that's kind of cool too that it can do is sometimes one of your dependencies doesn't really make sense in the browser. So let's say like I'm requiring something that like in Node.js, it makes sense for me to maybe like read some files off of the file system or store some stuff in the temp folder on your hard drive. That doesn't really make sense in the browser. So Browserify can do this thing where in your package JSON file, you can say that you want to take something, take one module that's being used in Node and replace it with a different module when Browserify is actually bundling up your code for the browser. So it'll just swap like one module for another, a browser version, if that makes sense.
Yeah, no, totally. So, and I think Browserify really helps us articulate the transformation from step one of your plan to step two of your plan. Because step one, like you said, you wanted to write, just a JavaScript BitTorrent client that just runs on your OS, and then in step two, you wanted to port it to run in the browser, and Browserify is like the articulation of this process of moving it from just a client-side application to the browser. I mean, still a client-side application, but now it's in the browser. Mm-hmm. And then so step three of your plan, you wanted to use WebRTC to create peer-to-peer connections. And, we've talked a little bit about WebRTC. WebRTC is this API for browser-to-browser applications, and it allows voice calling and video chat and peer-to-peer file sharing. Let's talk a little bit more about WebRTC and like when did WebRTC first appear, and how does it play such an important role in WebTorrent?
So before WebRTC, it wasn't possible to do peer-to-peer applications in the browser. The best you could do would be to make a WebSocket server and have your users on your website talk to each other through the WebSocket server. So a lot of sites still do this. This is how Facebook chat works. This is how you get like a lot of real-time like features that let you interact with other people on the web today. The downside, of course, is that this middleman can kind of see all the traffic, and there's manipulate it, record it, whatever they want. But I mean, another reason that has nothing to do with like privacy or security is just that it's actually slower because you have to go through this extra server, this extra hop in the middle. If I'm trying to send a message to you and we're both on the same site and we're trying to talk to each other, there's really no reason technically why it should have to go through a random server in the middle of nowhere. We should just connect to each other and talk. So that's what WebRTC enables. And it turns out that for certain applications like video calling or video chat or voice calling, you really want to have direct connection because the latency of going through a random middleman server would actually make the experience a lot worse, and it would make it like significantly there'd be a noticeable lag. and also the cost of the middleman to actually transit all that traffic would be substantial, because now they have to have this server sitting there that is just taking in all this video and sending out all this video, and really there's no point to all of it. I mean, they're not going to be saving it, or they're not really processing it. There's really no point for things to be designed that way. So a lot of applications like Skype will use peer-to-peer whenever they can. If you're on some really restrictive network, like a corporate network or something, you might not be able to directly connect to another person, especially if both of them are behind, or both of them are on corporate networks. So it's still useful to have that middleman there in those situations, so the call can at least work. But in general, peer-to-peer is preferable. So that's another reason why this was created. Actually, it's the primary reason why WebRTC was created. It was to enable really good voice calling and video chat in the web browser.
Okay. So I know we're running up against time, and I want to zoom out again and talk more about the project in the abstract. What are the engineering problems that are still unsolved in WebTorrent? What are you working on now?
Good question. So what I'm working on right now is I'm trying to make WebTorrent into a nice desktop application that people can use with a UI instead of just a command line application. So I'm hoping that people will start to use this client instead of Transmission or uTorrent or whatever other client they use today. At least some number of users. I mean, I don't need everybody to switch, but if some people start to use a WebTorrent powered client, then that means all the content that they're downloading and seeding will be made available to both normal BitTorrent peers and web browser peers. And so that's really exciting. And I think the reason why people might want to use this client that we're working on right now is just because it's going to have some features that normal desktop clients don't have. So you can actually stream torrents. You can start to play them back right away. You don't have to wait for the whole torrent to finish downloading. And I know some clients have tried this in the past, but it's been kind of flaky. There's been a lot of work in Node.js, in different Node.js modules that do this kind of torrent streaming, and it's proven to be pretty reliable. So I think some people might switch for that feature. And I want it to be really lightweight and simple, unlike a lot of the current clunky UIs that you see. I think Transmission does a pretty good job, actually. It's probably one of the better ones, but I think you can even simplify more than that. And so that's kind of what I'm going to try and do. And it's currently being built as an Electron app. So WebTorrent can just work because it will use the node parts of Electron, and it'll use the. So if people don't know, Electron is a project from GitHub that they built to create the Atom text editor.
Oh.
It's basically Chromium wrapped into a native wrapper. So you can build a native app, but use web technologies. So it's really.
Oh, no way.
Yeah.
That's how Atom works.
Yeah, Atom is just Chrome, really, inside, and then they're loading like their web app inside, and it has all these native integrations into the OS. So the JavaScript can do things that normally a page couldn't do. Like it can create notifications on your desktop, or access your file system, or put items in the menu bar and all the other stuff that you want a native app to be able to do.
That's really cool. Okay, so zooming out even further and looking into the future, you've given the use case of kind of the torrent-powered YouTube version, but given how much you've worked on this and how much you've thought about this, I know that you've got bigger thoughts about where WebTorrent could take us. What are some of the bolder use cases that like let's project forward 5 or 6 years or whatever, and you've got the WebTorrent version of YouTube going and it's fantastic, and then people are starting to adopt the technology and understand it and build on it. What are the more forward-looking, sophisticated use cases that you've thought about?
Yeah, I mean, I think there's a lot. It's really exciting, and there's probably use cases that I haven't thought of, but I know that the peer-assisted delivery use case is a good one. So that's basically sites that currently just host all their videos can kind of offload some of the work to WebTorrent. So Netflix was looking into this for a while to see if they could use something like WebTorrent. So that would be a really cool use case, I think, because it would make it cheaper for them to send out higher quality versions of the content on Netflix, and that would improve everyone's experience, and especially during peak hours, being able to use peer-to-peer would reduce a lot of internet congestion during the peak time when everybody starts to watch Netflix after coming home from work. There's also like file transfer, is sending files to friends is a pretty cool use case. There's a site called Instant.io that I made as a demo of this. So you can go there and drop some files onto your browser, and then you get a link and you can send it to a friend. And your friend goes to this link, and the file starts to get sent to them right away. And it's basically like Dropbox, but it doesn't require you to fully upload the file to the Dropbox server before your friend can start to download it. So if you're sitting in the same room, it's kind of silly to try and send a file to somebody that using Dropbox if it's really big, because it'll take like an hour to upload, and then, or maybe longer, and then they can start to download it. But you're literally sitting next to each other, and so using something like WebRTC to just stream the data across is really nice, because it's just peer-to-peer. So the data will actually never even leave your local network. It uses the best path that it can, and if you're just on the same Wi-Fi network, it'll just use that. So quickly sending files is a really good use case that a lot of people are already using it for. If you go to Instant.io, you can see the user experience of that site could be better, by the way, but it works.
It could also be worse.
Yeah, I guess. There's another one actually. Another guy, another couple guys actually built a better UX for the same idea. It's called File Pizza. You can go to file.pizza. File.pizza works exactly the same as Instant.io, except it looks way cooler because there's a rotating pizza that rotates while your file is getting downloaded.
Okay.
Yeah.
Well, this has been a super interesting conversation. I am really looking forward to seeing how your peer-to-peer vision of the internet evolves. I like how the way that we started the conversation here. You're talking about how the way that the web kind of originated was a little more decentralized, but your version, and then it's become a little more centralized. If some web server that we needed right now disappeared, then we would have a bunch of dead links. But you have a vision of a more decentralized internet that is sounds very achievable, which is in some contrast to some of the decentralization bulls that I've interviewed, like when I did weeks about cryptocurrencies and stuff, is a little more hand wavy and hard to understand where their vision of decentralization was going. But yours is a lot more well formed. Not to insult those other decentralization people, but anyway, I'm really excited about your work, and I'm glad to have been able to highlight it on Software Engineering Daily.
Thanks a lot, Jeff. It's been really fun.